got another one here for us that says the concentration. We have the concentration. The concentration of hydroxyl ions in a basic solution, in a basic solution is 0.01 mole per cubic decimeter. And already you can see, the minute you see mole per cubic decimeter, remember from our last previous episodes, we know that they're talking about concentration. Concentration is measured in moles per cubic decimeter. We must determine the pH of the solution. Now, like I always tell my kids, guys, a formula will always guide you. When we talk about pH, I'm going to write it on the side. We know that the formula for pH is equal to negative log and the concentration of the H3O plus ions. But in this case, they're telling us the concentration of the hydroxyl ions. And remember, let me make something going there. No. Hydroxyl ions is OH minus, which is in a basic solution. And H3O plus indicates in an acidic solution. So step numero uno, you must first determine or find the concentration for H3O plus. And to me, you're going to ask me now, Tobile, how do I do that? I'm going to school you. First things first, step number one. You can say, and now you find this from the KW of water, the ionization of water, where they say H3O plus, the concentration of H3O plus, and the concentration of OH minus are both equal to 1 times 10 to the negative 14. And remember, let me just go back to my beautiful diagram on this side. We got the 14 because and then 7 and then 0. So it's to the negative 14. But in this case, I am looking, I'm given the concentration of 0.1 for this hydroxyl ion, so which means I'm looking for H3O plus. Now remember, if you want the H3O plus by itself, you divide both sides with what is irritating what you're looking for. If you're looking for H3O plus, what's irritating it is the concentration of OH minus. What you do on the left, you must do on the right. I always say, if you buy a Mother's Day present, you must buy a Father's Day present. This and this will cancel. You are left with on this side the concentration of H3O plus as well as 1 times 10 to the negative 14. They've given us the concentration of the OH minus, which is 0.01. Now let's find what our concentration is. I would always put brackets on everything just so that your calculator doesn't act fancy. Negative 14. Oopsie daisy. And go there at the bottom. And then I've got 0.01. Close my bracket. So now I've got a value of 1 times 10 to the negative 12. But now this is the concentration of the H3O plus. I'm not done. The question says we must find the pH. So I've already have my formula here. I've got negative log. What is the concentration of the H3O plus? This is the concentration we've just calculated. So the concentration will be 1 times 10 to the negative 12. Back to our calculator. So I'm going to say negative log. And I'm going to have 1 times 10 to the exponent negative 12. Take that down. And then I get a value of 12. I get a value of 12. Now, back to the drawing board. I just want to show you guys this again. Remember, hydroxyl ions are OH, meaning it's in a basic solution. Remember, according to Arenas' theory, basic solutions will form OH and they will accept an H. So if this is 0, this is 7, and this is 14, anything close to 0 being very acidic, and anything close to 14 being very basic. Right. Now, this is not drawn to scale, but if I look at 12, and hypothetically speaking, if 12 was there, very close to 14, a bit far from 7 and very far from 0. So you can already see that between 7 and 14 is anything very basic. And my pH is 12, meaning it is in the basic side, very close to 14. And therefore, I can confirm that the concentration of the hydroxyl ions, which occurs only in a basic solution, can be confirmed by 12.